Today we will see how to design the C program for doing the Picard's method of numerically solving a ordinary differential equation. So let us consider कि we are trying to do this particular problem. And for the Picard's method, let me just mention at this point only कि for this method, as we know कि we have to calculate the integrals, right? So for the C programming, what we have to do, we have to just prepare these integrals, insert it in the program, and then design the program accordingly. But we know here for the pickers method, in order to obtain the desired level of accuracy, we have to go on calculating the integrals. For suppose here it was calculated up to 4 decimal places or 6 decimal places. For that it was sufficient to calculate up to this fourth integral. Okay, but it may happen ki you are given some more accuracy level, or suppose for the problem which is given, it is not sufficient for up to the number of integrals you are calculating. Then there will be step in the program which will just give the message ki this is not just matching the accuracy level, you have to insert some more approximation level. Okay, so that much will be the error message will be which will be coming there. Okay, so what we have to do before we start the programming, we have to calculate all these integrals. So for calculating all these integrals, as you know from the theory itself, suppose I am trying to calculate the value of y at the point 0 at the point 0.1. Okay, what we do, we use the initial values ki y equal to 1 1 when x equals to 0. Then the first approximation is calculated using y0 as this value 1 plus f of x0 y0. What is f here? F here is x plus y, this one. So 1 0, x is 0, y is 1, so 1 is here. So it becomes y0 means 1 plus dx of 1 integration. So ultimately you are getting 1 plus x, like that. Sorry, 1 plus x plus 1, because x plus y was there, x remains as it is, y is replaced by y0, so x plus 1. So you perform the integration, you are getting the first approximation expression, this one. Then what we do, we put the desired value here, x is 0.1, so y on, that is the first approximation of y at the point 0.1 is given to be this value. Again we go to the next approximation, we again follow the same procedure. Now f of x y1. Okay, so we are just following again the same thing. So x plus y, here we just put it here 1 plus, here you put x plus 1, because here already you have obtained the integration formula, just use it here. Okay, 1 plus x square by 2, so this one here, and then what, x was already there, so x plus y is now replaced by this y1 expression, so it becomes x plus 1 plus x square by 2 within the integration sign. Okay, so this comes again, you perform the integration, and the second expression, that is a at the second iteration state, the expression is ready. Now you put what, you put again the same value which is 0.1, and you calculate the second approximation. Okay, so this is how we move on. So for the time being, what in the program I have included only 4 integrations. As shown here, I have included only 4 levels of integration. Okay, if the accuracy maintained, then you need not calculate anymore. Otherwise the program itself will say, just give you the prompt you with the message key your accuracy is not maintained, you just insert some other approximation, some more approximation. Okay, so that you know, okay, then the fourth expression is not sufficient, I have to calculate the fifth expression, the sixth expression. You insert the fifth expression and again check if it is matching the accuracy, then it is okay. But if it is not matching the accuracy, then again you have to insert the sixth expression, and this goes on. Okay, so for the pickers method, let me just mention here that it cannot be done entirely by the C programming method. You have to do it partially by your hand, insert the expressions. Okay, and then you can use for the further step of this calculation using the C programming itself. Okay, now let us see the programming here. This is a standard thing which we are starting with, and I have kept, as I said, I am keeping this problem only, dy dx equals x plus y. You are trying to find out the approximate value of y at the point x equals to 0.1 as demanded there, and the initial value is y at the point 0 is 1. Okay, so these are some of the variables which we have declared. X0 is 0, y0 is 1. You see here ki unlike the other programs, we have to provide it at the very beginning only, because until and unless you know what is y0, how you are calculating these integrations. Here only I am using to 1 plus here y0, then x plus y, in place of y I am putting y0 again. So once we are trying to design the program, we should have the idea what is the value of y0. I cannot ask the user to provide it again. You can ask it, but it is useless because you already have to have the knowledge of it. Otherwise, you cannot design these integral expressions. Okay, so I am not asking the user anymore to provide it. I am taking it on its own as the input, as this one. Okay, and then what I have to ask for the user, you have to ask he provide the value of x for which y is to be determined. So here it is 0.1. Okay, so user should provide it with 0.1. Okay, and also the accuracy, for the accuracy we have to enter, the user has to enter the maximum allowed error. Okay, so this one is stored inside x1 and this one is stored in the variable aerr. Okay, and then you are giving the output as the printing part. Okay, and then these are the integral expressions, that is the expressions derived from the integration following the strategy of the Picard's method itself. And as I said, I have included four integrations, four expressions. Okay, if it doesn't suffice the accuracy level, then you have to increase it. Okay, you have to enter here. So as I said, this part of the program and also this one, you have to design, this one will be given, but you have to incorporate it at the very beginning only. And this one you have to go on changing if your accuracy level is not met with. Okay, and then what we do, we have to calculate, what we have to do, we have to calculate the value of each of this expression at the desired point. The desired point means at the point x1. Okay, that is 0.1. So that is what I am doing here. If for I running from 1 up to 4, why 4? Because I have calculated only these four expressions, so it will go up to 4. If you increase it, then obviously we will get some just arbitrary values because we have not at all calculated them. And if you decrease it, then you obviously you are just decreasing the accuracy level here. Okay, so the suggestion is ki if you are calculating 4, if you are incorporating 4 expressions, then run the loop up to 4 only. No need of running it or stopping before that. Okay, and at which, suppose it is the case ki at third iteration only I am getting the value, that will be shown here ki at what iteration level you are getting the value. Okay, acha. Now for this one, what you are doing, you are printing what we are printing, y at the point x1, right? So y at the point x1 at percent d step. That means at first step this is the value, at second step this is the value, third step. So at each step your value is shown here. So this is done within this loop. Now comes the checking part for the accuracy. So I initialize the integer type variable to be 0, k equal to 0. Now while error you see I have initialized to be 1. Okay, now if error is greater than the allowed error, then what will happen, this loop will run. What will happen inside the loop, there is another loop of conditioning loop for the if k equal to 4. Why 4? Because we have taken only 4 expressions. If accuracy is met within this, then okay, otherwise the program has to give the message ki this is not working, you have to increase the approximation. So if k equal to 4, this is the message will be which will be displayed, which is sorry displayed, and then it will break. That means the whole loop will break and the program will stop. Okay, so printf is accuracy level not obtained, define percent dth approximation formula. Percent dth is what, k plus 1. So if k equal to 4, then you have to enter the fifth. Then that means the program is prompting you that whatever you have entered till now is not sufficient to derive the answer up to the accuracy you are demanding. You better incorporate y5 y6 like that. So that is the message which is displayed. Okay, so once it is done, then it will run the break. That means it will just come out of this loop. Okay, and else, that means if k not equal to 4, what will happen, k will increase by k plus 1. So initialize k equal to 0. So k will increase by k plus 1 means now it will first become 1. So at the first step already I have calculated the value. Okay, so once I have calculated the value, what I will do, I will check the error y1 and yk minus 1. Achha, one thing here, it would have been better if I would have started from k equal to 1 itself. Okay, for why I am saying k equal to 1, because y of k minus 1, that means if it becomes 0, if I put k equal to 0 there. Okay, because k equal to 0 means k equal to k plus 1 becomes k equal to 1, then y1 minus y0, but y0 I have not at all calculated. Okay, then that should give an arbitrary value. Obviously it will run because it will be something greater than 0, and obviously error is, we have initialized to be 1, so obviously error will be greater than that whatever arbitrary value will be coming here. But it will be better and obviously it will be accurate if you give here k equal to 1. Okay, so here it becomes, after k equal to k plus 1, it becomes k equal to 2. So you are just putting inside or updating the variable error as absolute value difference of y2 minus y1. Y2 already you have calculated and y1 also you have calculated. Okay, so you are getting the value here. Achha, another thing we should be mentioned, or you should have noted here, these are not the expressions actually. These are the expressions along with the point of concern being put. I'm not putting x, I'm putting x1. And x1 is what? The required value where y is to be determined. That means actually I'm calculating these values in short. This value I am calculating. I'm not bothered about this expression anymore. Okay. I'm directly calculating the value. Here, this value, then this value, like this. This is y4, this is y3, this is y2, and this is y1. Okay. Achha. Then, once you are calculating this thing, error is getting updated at each step. Okay. And as long as error is greater than this, if k equal to 4 is reached, then this error message is coming. If k not equal to 4, then you are updating the error by this absolute value difference. Okay. And then if error is less than the allowed error, what will happen? So k loop is running up to this, right? Sorry, while loop is running up to this. Let me just see here, while loop is running up to this one. Okay, so it is stopping here. Okay, now for error is less than allowed error, if it is the case key error is less than allowed error, then what will happen? You have already obtained the accuracy level, so you should be giving the output. So this is what it is done here. The value of y at the point x1 is obtained at which step you are obtaining it. It is given here at percent this step. Okay, and what is the value of y? This is printed here. The required value of y is at the point obviously x1 is this much. Okay, correct up to I have 4 decimal places, or I will better remove this so that you do not get confused here what accuracy level is maintained here. It will be obviously according to the question which is set. So I better remove this one here. Correct up to you have to put once you do the program yourself. Okay, so this is printed here. Okay, and then it is ending here return 0. Okay, so let me run and see what happens. Okay, so 0.1 is a value, a point where we are trying to determine the y's value, and let me just set its accuracy error allowed error to be 0. This one. So that means what? Up to 2 decimal places your answer will be accurate. So this one you see y1, y at the point this, all of the y at the point this, and then it is the value of the first step of iteration, second, third, fourth. But what I demanded, the error allowed error to be 0.0001. So that means up to 2 decimal places this should be right. So it is occurring at the, you may say, the third step only, or at the fourth step also you may say the value of y this is obtained at the fourth step, this one. Okay, so this is the thing which we are getting here. And so what is the value, required value of y? This is the required value of y. Okay, so it is ended here. Now let me just increase the accuracy level so as to see whether the other part of the if loop is running or not. Okay, so let us run it again, then put the value, then let me just increase the accuracy level. The error I am allowing up to this. Okay, maximum allowed error up to this I am allowing. Okay, so now you see this much I am giving the allowed error. Okay, so this is the error message which is coming. Define the fifth approximation formula. Okay, it is not giving you the accurate value anymore. It is giving you only the values which are calculated from the expressions you have entered. Then it is saying okay, accuracy level not obtained, because here up to how many places I have given, max minimum 6 or 7 I have given here, so it is not maintained here. So as you can see, it is accurate up to 4 decimal places, or rather up to rounding you can incorporate up to 5 decimal places, but after 6 decimal places only the error is more than whatever is said here. Okay, so if the error is more than the allowed error, then obviously accuracy is not reached. Okay, So that means you have to go for the fifth approximation formula. You have to incorporate this one as y5, and then you have to again check if y5 sufficient, then it's okay. If not, then you have to incorporate y6, and this goes on. Okay. So this is the Picard's formula by the C programming. Okay. So let us stop here.